So now we have just added to our system some complexities, because right now you do not just store, for example, the program counter or the memory or the stack. You also need to store things such as what is the status of the process. Is it ready? Is it in the ready state? Is it in the blocked state? Is it running? And so on. So that the scheduler, the operating system, can use this information to actually decide on what to do next. And operating systems are actually very rich in data structures. We'll actually cover quite a bit of that in our parallel Linux lectures, which, by the way, will start tomorrow. I will upload the first video. So the process control block, for example, again, back to this data structures, the PCB, which I mentioned briefly before, stores information about each process. We'll also look at this in the Linux kernel. And you have another data structure that is the process list, which keeps track of all processes. Basically, it points to all the process control blocks. Basically, it puts them in whatever data structure you can put it in a linked list, for example. So you'll have process control block 1 for process 1, process 2 control block, process 3 control block, all of these in the process list. This is an example of some of the data structures that you might find in an operating system. This is the XV6 operating system. And it is actually something that is Unix-like. It's not exactly Unix. We'll look at the equivalent of this in Linux, actually. So this is just an example of one operating system that exists on Earth out of hundreds, where you have basically a process control block, a PCB here, okay, which basically have like different registers that you keep track of, and these are your registers. Okay, struct context, it keeps the context, everything regarding the basically the different registers, and this will include your stack pointer. So ESP is basically your stack pointer, and so on. And there are different states that a process can be in this operating system. One of them is unused, embryo, sleeping, runnable, running, and zombie. I mean, this is basically an implementation, one example of an operating system. For exam like questions, I will never come and ask you please tell me what are the states in the XV6, because I do not care. I just want you to understand the concepts rather than what are the names of these things, just noting. This is basically an example of a structure where you have the structure of the process and you have a pointer to the memory, you have the size of the process memory, you have how large is the kernel stack, you have the bottom of the kernel stack, sorry, you have the state, you have the PID, and so on and so forth. So, I mean, this is one example. So let me ask a question. Which of the following process state transitions occur when a process completes an IO request? Please pick your choice.